Hi, today I'm going to be discussing a current sensing issue. This is not going to be a real-time repair, but I am going to actually show you the work that I did in the microscope camera. I am actually going to be keeping this camera here and not moving it so that when I start these repairs, it's as simple as just hitting a button. Now that I am a Windows user and not a Linux user, I don't have to torture myself when I want to do a video. It just works. I mean, I'm a Linux user for my own personal laptop. I am not a fan of Windows. I haven't been for a long time, but it just kind of got old dealing with editors crashing and things you think it's recording, but it's really not, and it's just blah. And one of the cool things I can do here is I can actually see exactly what's in my microscope camera on the screen without having to have a splitter. It's just really, really cool. Anyway, so today I'm going to be going over a current sensing issue. So let me switch over to the microscope camera, which is now literally as easy as me just scrolling and hitting a button. Alrighty, so I can show you over here what I did. And let me just turn the light down because the camera does not like light nearly as much as my eyes do. Alrighty, this is a new lens, so I kind of got to get used to what looks good in this lens. I don't think this is as good as my other one, but I can't figure out how to make my other lens work, and I don't know why it decided to stop working for no reason, so not much that I can do there. Alrighty, so yeah, you can probably take a guess where the work occurred. This definitely doesn't look as good as my other lens, but what are you going to do? Anyway, so we can take a look here, and you can see that I have a wire going from this resistor to this capacitor, and then to this pin of the ISL 6259. And even though it looks nasty, it actually was done with proper flux on there and some good solder. You can see I'm not going to weigh at this. It's not going to move. It's not going to come off. It's fine. And I'm also not going to push my luck by continuing to do that. No, not one bit. So let me just show you a little bit on the screen capture what it is I actually did. And this is so cool. I can just switch back and forth seamlessly between these different sources. Look at that. Look at that. It's fucking seamless. I mean, I'm not even going to have to do editing anymore with adding transitions. I can just go boop, boop, boop. It just works. So I'm going to open the board view and I'm going to show you what that is. I'm going to try to explain some of the circuit. And then after that, I'm going to go the fuck home because it is late and I'm tired. Okay. Let me just switch over to... This is one of the other things I don't like about Windows 8. I mean, I just open something. It automatically opens to this full screen mode, but there's no way for me to get out of the full screen mode. So I want to go over and change over to this software so I can go back to the screen capture, but no. Okay, here we go. So you should be seeing my screen right now. Let's just zoom in a little. Hopefully it doesn't look like crap since it's getting redone to 1080p for YouTube. Okay. So the resistors, these are current sensing resistors. So the way this works is, as I've explained in other videos, the computer cannot actually sense how much current or amperage the computer is using. It has no way of sensing how much actual wattage the computer is using. It can sense voltage, but it cannot sense amperage. It's important to be able to sense amperage. You know that the machine is running off of 17 or 18 volts. You know that's what the charger is providing. But how do you know how much power the charger is putting out? Is it putting out 18 volts at 1 amp? Is it trying to put out 18 volts at 10 amps? If it's putting out 18 volts at 1 amp, the computer is going to say, okay, fine. If the computer thinks it's trying to use 10 amps, obviously it should turn itself off so that the charger doesn't blow up and destroy your home and have shrapnel of little Apple chargers going into your eyeballs. The way this is done is through a current sensing circuit. So you can actually see the cursor now because I have an operating system that just works. Anyway, so right over here is a current sensing resistor. So the way this works, this is a resistor with a very, very, very low resistance. So this is 0.02 ohms. This is very, very low resistance. And the way this works is, here's the power coming from the charger. So you have from adapter up here. It's going to go from the adapter. Ignore this whole confusing transistor shit over here. The whole point of this is just pretty much it allowing the charger to come into the machine. So all this stuff up here, don't be confused by it. That really is just the ISL chip over here telling the transistor you can allow the charger to come through. If the ISL does not open this transistor, it will not let the charger through. A transistor is pretty much a gate. So the charger gets over here and then it gets told by this transistor, can I open and can I, come through to the machine, or am I stuck over here? The transistor will enter infinite resistance if the ISL tells it that it's not allowed to go. So back to the points. You have the power coming from the charger going through here. Now it goes through the 0.02 ohm resistor, which is pretty negligible. There's going to be virtually no power drop across that circuit. The charger is not going to have to work harder because of this resistor. However, there will be a really, really small voltage drop across here. And the voltage at the top of this resistor and the voltage at the bottom of this resistor, they're going to be different. And the ISL can actually tell how much amperage the computer is using based on preset values that are put into it, based on the voltage at the top and the voltage at the bottom of this resistor. So the voltage at the top of this resistor will be different from the voltage at the bottom. Now over here you have these two 10 ohm resistors. You have R7021 and R7022 that go directly to the ISL. Now there's going to be a capacitor to ground at each one to get rid of ripple voltage, and then there's also a capacitor between the two. The main thing that's really important here are these two 10 ohm resistors. So if the traces between the current sensing resistor and the resistor going to the ISL, or the trace between the current sensing resistor here and the ISL are blown, it's not going to work. Further, if these resistors are not 10 ohms, they're not going to send the proper power to the ISL, and it's not going to know what's going on. The ISL 6259 right over here, it needs to know what the voltage is at the top of this resistor and the bottom of this resistor. When it knows what the voltage is at the top and the bottom of this resistor, when it knows what the voltage drop is, and also what the starting voltage is, it can calculate through formulas that are far too complicated for me to explain here, exactly what amperage the circuit is using. So what happens is, a lot of the time, if it thinks it's using more power than it is, it's not actually going to send PP bus G3 hot, which is the main 12.6 volt rail. It's not going to allow that to be created. It's not going to send the charger to those transistors that create PP bus G3 hot. You're not going to get anything. So if the current sensing is not working, you're not going to get enough power to the system. Sometimes this will sometimes this will manifest as the system simply not turning on ever, not charging the battery ever. Sometimes it'll manifest as it will only charge the battery when the machine is sleeping or turned off. So it's using less power to charge the battery than it is to charge the battery and power the system. So the current sensing circuit will only kick in when it's turned on and trying to charge the battery. It won't kick in when it's closed. So if you have the charger is orange, but then you turn the computer on and it turns green and it's not charging, you kind of know that you have a current sensing issue. So let's look at the board view over here so that I can see and give you an idea of what blew, and you can see what I interconnected. Now let's look at this on the board view for a moment here. So you can see that you have R7022 over here and R7021 over here. So those are the same as R7022 here, the bottom current sensing resistor, and R7021 over here, the top current sensing resistor that come from this main current sensing resistor. Then you have these two capacitors going to ground, so this is taking the low side of the current sensing resistor and sending the ripple to ground, and this is for the high side current sensing resistor, and that's the capacitor sending it to ground. So that capacitor over there is this one, see, C7021 and C7022. So this is the current sensing resistor. These are the two resistors between the current sensing resistor and the ISL, from the top of the current sensing resistor and the bottom. And these are the capacitors that send the ripple voltage that may be present on either to ground. So you have two resistors, two capacitors, and then one capacitor between them. And it's very much set up that way in the board view. So you see, it's not that scary. You have your two resistors over here, R7021, R7022. You have C7021 and C7022. And then you have C7020, the capacitor going between them. Now, just to remind you, because you probably are getting confused at this point by all this mumbo-jumbo bullshit that I'm talking about, let me just show you on the microscope. And again, you can get an idea as to why this is not crazy hard. And hey, let me just put the light up a little. I'm not liking this lens as much as my other one, but oh well, what are you going to do? So again, see, this was burned. There was no trace here. And it's really obvious to see because you see this over here. Come on, it's burned. It's destroyed. It's killed. Let me just see if I can turn this up on the magnification a little so that you can get a little bit of a better idea of what it is I'm talking about. Okay, this is at 30x, which is... yeah, it's really hard to get focus on 30x. But you can see that this is... like this over here is done for. So that... yeah, see that was going to that on the ISL. This one is nice and healthy. So the one on the left is healthy. I really don't like this lens compared to my old one. What are you going to do? And this was just destroyed up here. So this is pretty much what got ruined. So just to go back to where we were. you can see this is a line. So from here, this goes to this resistor. This resistor goes to this capacitor, where this capacitor will take the ripple AC voltage on here and send it to ground so it doesn't screw with the circuit. And then it goes directly to the ISL. This is the low side, CSIN, current sensing. I'm honestly guessing I is something that means charger, and N means the negative of a data line or a data signal. Then you have the top. This is the top of that resistor. So that is sending the voltage through this 10 ohm resistor. Then you have a capacitor that takes it to ground just so that this, doesn't fluctuate with AC. And then you have this coupling capacitor between them. And that is pretty much the line. So you have one line from here to here, then you have one line from here to here, and one of those lines was completely destroyed. And I honestly don't even remember if I measured this resistor to see what it was. Oftentimes, instead of being 10 ohms, you'll notice that it's 500 ohms or infinite ohms, which means, totally destroyed. I honestly didn't even bother measuring it because it's a 10 ohm resistor. I might as well replace it. If this got burned, and this got burned, and this got burned, you can bet your ass this probably got burned. So I replaced it all, and you can see what that looked like in the microscope, and that's that. So that is a common issue that occurs. And I hate that it automatically does the PDF reader full screen, but what are you gonna do? It is Windows. I like the fact that Windows works. I like the fact that I can actually edit video and capture video without headache and without Kdenlive crashing every 5 seconds. I like a lot of things about Windows. Like my graphics card, the heat pipe actually gets hot now. So before, when it was winter in here, my graphics card, you could touch it. You get frostbite on your hand because, Linux graphics drivers, they don't even know how to turn the thing on besides, output or output video to screen. That's about it. Anything else you don't get. Here I can actually use that for fast video editing. I can use it, I can switch back and forth between different sources, clicking. I don't have any bugs where I think I'm recording, but it's not actually recording just because V4L2 doesn't decide to. But some things about Windows 8.1 just kind of drive me nuts. Like, again, just basic applications. Like, how am I supposed to go back to what I'm doing besides... Okay, well now it wants to show the taskbar. Well, you weren't doing that before, you See, now it doesn't want to... there we go. It's just going to make you look like me. Windows is great at just making me feel and look like a moron. But anyway, yeah, so... that is current sensing, and what I like to do with all these videos, and I don't always have time to, is show you that the work actually worked. Because again, if I always say in these videos, you should take advice from people who are successful, or people who are doing things that actually work. And, what type of hypocrite would I be if I didn't actually show you this thing working? So before this would work off the battery, it would show you the charger was connected, but it wouldn't charge the battery. And the problem that you would have with this thing is that it would have a green light, it would say not charging. If you unplug the battery, it would instantly go off. It was only providing 1.7 volts on PP bus G3 hot. And as the schematic says, PP bus G3 hot, which is the main power rail of the machine, controlled by that chip in that circuit I showed you, that's supposed to be 12.6 volts. Now over here you can see that I have unplugged the battery. So I have to do manual focus because I have this thing set on face detection, which means it's not going to see anything I want to focus on. You can see, I'm not going to waste time on manual focus. You can see the battery is unplugged. You can see the fans are spinning. And you can also see that we're loading an operating system. We are loading an operating system with a spinning 5400 RPM hard drive. That is what Apple in 2013 saw fit to put into this computer. That cost about $2,000. Again, if you think you're getting, top performing hardware over other stuff when you buy an Apple product, think again. See that cheap ass spinning hard drive? You spend $2,000 on a laptop computer. You don't get an SSD. That's what you get in 2013. Anyway, it is working without the battery plugged in, and I would also like to wait for it to get into the operating system, which again, Hitachi 5400 RPM drive. This is gonna take a while. So I hope I got some hard drive space because we got some time to kill. So I'll wait for it to get into the OS, and then I will show you. Okay, as you can see, it is charging the battery. I moved the camera away from the desktop because I don't want you guys stalking this person based on their files or anything that may show up. Stranger things have happened. But it is charging the battery. It does know that it's going to be full at a certain time. It does work when the battery is not plugged in. And of course, it does function off of the battery. So all of the functionality within the U7000 circuit are functioning perfectly fine, which means that my job is done and I am happy. Again, if you have any questions, post them in the comments. If you want to know where I get schematics, don't ask. I don't plan on telling you. You're going to have to Google for that. I don't distribute schematics, and you should know why if you watched my Right to Repair video. And if you have any questions on how to fix these boards, you should join the advancedreworks.com forum. That's advancedreworks.com/forum, where we, on a daily basis, have a lot of technicians that discuss component level repairs, how to do component level repairs, what tools you should buy. The owner of the website even sells some tools required for soldering and BGA rework, and that's about it.